This is practice test 3, number 4. All right, so we're going to start with problem number A. Everybody's paying attention because we have a test on Thursday. And for some of you, this could make a big difference in your grades. So let's do really well. Right, Miss Brownlow? Really well. All right, here we go. How do I solve this equation?
Find a way times the x.
Okay, we're on number 4, Katie.
Oh.
That's good. That's good for one of the other questions. But turn to the next page. We're going to solve all these equations first today. We'll go back and get your problem if we need to. How do I start this? 2 to the third equals 2x minus 1. Julie, did you find the paper I laid there for you?
Yes, thank you.
So 8 equals 2x minus 1. 2x equals 9, and x equals 9/2. When we solve a logarithmic equation that has just one logarithm in it, we have to rewrite it. 2 to the third equals 2x minus 1. Thomas Berg, we talked about this a zillion times the other day. 2 to the third equals 2x minus 1, right? 2 to the third is 8, and then we just have a regular equation to solve. Anybody have a question about that one? Kaylin, you with me? Okay. Number B, or letter B. Tell me about the first step. Divide, divide, divide. So 4 to the x equals 160 divided by 5, which is 32. Now, this is a no calculator problem. If you're going to solve this without a calculator, you have to be able to do what with those two numbers? Make them match. So I see a 4 and I see a 32. Change them to 2's. 4 is 2 squared. Gibran, I need you quiet and attentive. What's 32? 2 to the 5th. Now 2 to the 2x, remember we multiply these, equals 2 to the 5th. What do I do at this point? I made my numbers match. Why did I make them match? So that I could cross them off and say 2x equals 5. Set my exponents equal, like Julia said. So what does x equal? 5/2. Maya McLaurin, when you look at this problem, what pops into your head? I could make the -2 an exponent. I absolutely could. Very good, Maya. In this particular problem, what else could I do, though? I could divide it. Now, I can't always divide, Maya, so what you said will work every time. It's going to make my problem easier this time if I just divide, since division is a possibility. And that will leave me with log x equal to -2. Now that is a simpler version of this. How many logarithms do you see here? 1. What do you do when you have an equation that only has one logarithm in it? Will? You rewrite it. And in order to rewrite it, we're going to need to know the base, and the base is 10. So how will that get rewritten? 10 to the -2 equals x. What does 10 to the -2 mean? 1 over 10 squared, which is 1 over 100. Perfect. This is a freak out problem. guys talk about the problems, that's awesome. When they take our tables away, I'm gonna be upset, cause we're not gonna have this kind of conversation.
Because they're gonna tables away?
Probably, when they
Why?
bring in the new furniture.
And what kind of furniture are we getting? It might
I'm
be an
not
upgrade.
sure. We'll have to wait and see, I don't
I
know.
think with the tables, and we end up with death,
Yeah.
I would be outraged.
I kinda like my tables now too, but oh well.
Someone
All
get
right,
slapped.
look, this problem looks so hard, but it isn't. What's the first thing you're gonna wanna do? Well, you're gonna divide by an 8. I mean, we say we wanna divide, but since it's a fraction, we'll multiply by 8. So we're gonna multiply both sides by 8. That will leave me with 2 to the 3x over 4 equal to 64. Now we're right back to where we were here, guys. You're gonna solve this without a calculator. You have to be able to make those two numbers match. There's not much you can do with 2, but what about 64? 2 to the 6th. So 2 to the 3x over 4 equals 2 to the 6th.
Cross out the 2.
So 3x over 4 equals 6. What do you want to do to solve that? Multiply by 4. And then,
Divide by 12.
by what?
Never mind.
Divide by 3. So x equals 8. So what looked like a really hideous problem really wasn't bad. Don't get psyched out. Okay, how about this? What do we divide? So these two things, we're going to take these two logarithms and we're going to squish them into one. And when we squish them, we're going to divide these two things. Now, does everybody understand why they're being divided? Sometimes they're multiplied, right? When are they multiplied? When as an add. Now, this is the third problem exactly like this we've done today. How many logarithms are there here? 1. When you have an equation with one logarithm, what do you do with it? You rewrite it. And how will this get rewritten? 4 to the third equals 2x over x plus 1. Bryce Acreage, 4 to the third equals 2x over x plus 1. What's 4 to the third, Bryce?
48. Nope.
4 times 4 times 4?
4.
16 times 4, that's 64. Jack Rocap, how do I solve that?
Multiply by x plus 1.
And when I multiply by x plus 1, it's a distributive, right? So it's going to be 64x plus 64. Everybody catch that? That's a distributive. Would I bring it over? I multiply by x plus 1. So 64 is going to equal negative 62x. So I'm going to divide by negative 62, and x equals negative 32 over 31 when I reduce that. That is an extraneous root. There's no solution to this problem. Why is it extraneous? Can anybody explain it? Okay, now, Katie, that's part of it.
There's a bigger number on the top.
I want you to look, Katie, where's this problem start? Right here? I want you to look. If I put in negative 32/31s right here, wouldn't that guy be negative? And do you remember we had an exercise of problems in the book where we typed in the logarithm of a negative number? What happened? It said no solution or error or something like that. This right here in the circle can never be negative. So if you're telling me to plug this into that, I'm saying I can't do that. That's why there's no answer.
Can we put no solution?
You put no solution. Hey, we're almost done with this section, which is great.
Because if you plug in negative 32.
Okay? Step one,
And the problem to get a negative 5.
squish, right? These have got to get squished. And once again, did I copy that right? Yep. They're going to go together as a division. But this, for the first time today, is a different kind of problem. The last one had only one logarithm in it, so we had to rewrite 4 to the third. This is not like that. This has a logarithm on both sides. So Taylor Holder, what do I do when I got a logarithm on both sides? Drop them out. Very good. Did you know that, or somebody say that over there? You had help, didn't you? X plus 1 over x equals 5.
What happened?
These get dropped out, remember? So x plus 1 equals 5. X plus 1 equals 5x. 4x equals 1, and it looks like x equals 1/4. All right, I think you can do this one. Let's see. Jared, got an idea about this problem? Don't you say no idea. I know you have an idea. We're going to solve this without a calculator. So what do we have to do with these two numbers? They got to match. Okay? Now, you've got a 4 and an 8. Can you make them match? How? Okay? It's a good thought. 8 is not 4 squared. So I can't really, okay, no, you're right. I'm going to go with 2's. So what's 4? 2 squared. What's 8? To the, yep, perfect. That's exactly what you want to do, Jared. That's exactly the right strategy. We're going to change the 4 and the 8 into 2's. So now we have 2 to the 2x equals 2 cubed. Why did we make them match? So that we could drop them out. So 2x equals 3 and x equals 3/2. Maya Brownlow, you're up next. A little heads up back there. All right, now think about this for a minute, Maya. First of all, what does LN stand for? It's a logarithm, Maya, and what's its base? Yeah. So this is just another way of writing the problem. Now it looks like 3 other ones that we've done today. I have a logarithmic equation with a logarithm on one side only. Well, when I only have one logarithm, I have to rewrite it in its exponent form.
Hold on, I just said it to Bryce, and Bryce said I was right, so let me just say that here in public. E squared equals X.
Bingo. And that's the answer to the question. We're done. We're moving on. That's it. Good job. Okay. The very last one. Paige Grimmer. This is a no-brainer, I think, for you. Tell me how to solve that.
It's 7 squared equals X.
You are exactly right. So we will put 49 down.
I have a question before I forget.
Yes.
It's not on this page, but it's a quick one on this one. How do you know whether to plus or minus one? Like this one minus this one?
Well, if it times, it's added. Okay. Let's turn the page and look at number 5. Write as a single logarithm. Now you have already done some squishing today, and that's what you're doing. You're going to squish these two together. However, I threw a curveball in there, didn't I, Ethan Topham? What's the curveball in there? We're on number 5. The 3. The 3's an issue. What do I do with the 3? It's an exponent. So step 1 is not squishing. Step 1 is dealing with the 3. It becomes an exponent. Now I can squish.
Squish them.
So when I squish these and make one logarithm, is it going to be a times or a divide? Divide. X over y cubed. Perfectly done. Beautifully done. Number 6 is exactly the opposite. Now we're pulling it apart. These two things are being times. Jordan Bruns. These two things are being times. Right?
Right.
So when I pull them apart, I will pull them apart as a what? What sign's going to be in there? A plus. Very good. But you aren't done. The 2 has to be dealt with. And Abby Brady, where is the 2 going to go, Abby? Yes. So I'm going to have 2 log x plus log y. Now we have 2 ways we can go. We can start in on the calculator part, or we can do page 1. What did you prefer?
Calculator.
Calculator part. Okay, number 7 then. This is the calculator part. Number 7. All right, how do I do this problem? Exactly, Olivia. The same way we've done 4 others today. We rewrite 6 to the x equals 13. Now, Megan Lenahan, in a perfect world, hey, when I'm talking to you, turn around and look at me. In a perfect world, I would be able to make these 2 match, right? But I can't. So what do I have to do? Exactly. I have to take the logarithm of both sides. And, Mr. Troy, when I take the logarithm of both sides, what happens to that little x right there? He comes out in front. And then Tim Kelly, if I want to know what x equals, I will type what into my calculator? Yep, and Tim, when you do that, what do you get? 1.43. Somebody confirm that. I didn't type it in.
Yeah.
Yep, is that right? So take a look at that. Remember, if it's on the practice test, it's on the test. So you need to be able to do this all by yourself. Anything here bother you? Step 1, rewrite. Step 2, take the logarithm. Step 3, pull the exponent off. Step 4, divide. All right, here's B. We have already done a problem that looks like this. What is step 1?
Oh, you gotta divide that
You've
four.
got to divide. So 3 to the x equals 15/4. Now we're right back to where we were with Megan. In a perfect world, you would get these two to match. That is not going to happen. So what do we have to do? Stop. What did Megan tell us to do over here? We have to take the logarithm of both sides. Can somebody explain to me why I'm taking the logarithm of both sides? What is the awesome thing that happens in the very next step?
You can divide the log.
The exponent, oh! The exponent, knocked my chimney off, got so excited. The exponent, which is the x, comes out in front.
Wait, is the iPad on?
Yeah, that's all I'm doing.
Is that how you scream? Like, you're in danger? Is that the noise you make?
X equals the log of 15/4 divided by the log of 3. Who's typed that in?
Me,
What'd you get?
1.2.
And usually we want more decimal places.
1.20. 3.
Okay, anybody confirm 1.203 for that one? And finally, number C, or letter C. Madison, step 1.
Divide by.
Perfect.
Yep.
Now, Veronica, we are exactly at the same place we were at the previous problem. We were right here. We got these numbers this time, but we can't make them match. So what are we going to do? What did we do over here? We're going to log both sides, except because there's an E in the problem, we'll ln both sides. And the reason, Veronica, that we chose to do that, remember, we can log. That is not an issue. But it's easier if you ln, because see these two guys right here? They're gone. So we have 1.3x equal to ln 17/4.
Yep.
So x will equal ln 17/4 divided by 1.3. I need somebody to type that in. Remember, you are lning. Maya, dear, what you doing back there, honey?
Huh?
What you doing?
I'm right here too.
What did we get here? 1.11? Anybody confirm 1.11?
Yeah, Katie got that.
Katie got that, good. All right, now we have a choice. We can either do the word problems on the back, or we can do page 1.
Word problem.
Word problems, all right. Remember, whatever we don't get done is homework. Okay, A.
Yeah,
My formulas are still there, so you got to tell me which one am I using, top or bottom, for A? Top, because it says compounded quarterly. How long will it take an investment of $150 to double if the bank pays this much interest compounded quarterly? Okay, what goes where?
All right, 150 is the P.
Thank you.
Then, X is gonna be the X.
No.
No, it's the A, there's no,
I'm going to double the investment. So what am I going to end up with? A is 300. I am going to end up with 300, aren't I, if I double it?
all right, then for R, you put 1.75, or 0, .0717.
Yep, that's right, 0.0175 divided by 4, because why? It's quarterly. And then my exponent will be 4t. Right? 4t. Now notice your exponent is the variable, so that means eventually we're going to use logarithms. But not in step 1. What do I do in step 1? Divide. That's our common theme. We always divide. We should make a cheer. Step 1, divide. So we get 2. So we get this. Now, if this guy bothers you, then you can go ahead and do 1 plus 0.0175 divided by 4 and write 1.004375. Now, I don't know if that helps or hurts, but if you would rather have a single number here instead of that, you can do that. Maya?
So this you just plug it into the calculator, what you get out shows you the answer.
Well, eventually I'm going to do that, but first I have to find t. My job is to figure out what t equals. So Maya, I'm going to need to take the logarithm of both sides at this point. And the reason, Maya, that I am doing that is so what will happen to that exponent? That exponent comes out in front. So I'm going to have the log of 2 equals 4t times the log of 1.004375. Now I'm solving for t. So I'm going to have to take the log of 2 and do what with it? How am I going to get t by itself?
You're going to have to divide by log.
I'm going to have to divide by this number and by this number, right? So I'm going to take the log of 2 and I'm going to divide it by 4 and hit equals. And then I'm going to divide it by the log of 1.004375. And I got 39.69 years.
Is it really?
All right, B. Here we go, let's get these set up. B. Which formula?
First.
Yep, same one. So, what goes where? Isn't P 9876?
Yep.
Okay.
It's like almost like a
How many years am I leaving this in there?
25.
some of them have
25. Okay, I know we're getting up clear near the end of the period. We're starting to lose a little bit of attention, but we got to stay focused. Look at this. Does this setup look okay to everybody? I am joyful because here's my variable. That means I'm just going to type it in, Maya. This is one where I'm just going to type, and get my answer. So I'm going to start right here with the circle. 1 plus 0.02125 divided by 12. Oh, wait, I didn't do this. That's that's 300. So once I get this typed in, I'm going to raise it to the 300th power and then times it by 9876. and that's how much money I will end up with. Last one on this page. Does everybody recognize that the last one is a PERT?
Yeah.
How's come? It's not money. So 4, 5, 6, 7 is what I'm starting with. 8, 8, 8, 8 is what I'm ending with. E to the 0.234t. Take a look at my setup. Obviously, you can't get the right answer if you don't set it up right. I'm ending with 8, 8, 8, 8, starting with 4, 5, 6, 7. My growth constant's 0.234. Step 1, divide. ln both sides, very good. And Jack, what's going to happen over here on the right when I ln? Those are going to cancel. So I will type in my calculator, ln 8888 over 4567, divided by 0.234. Can we do that in a couple of seconds here? ln 8888 divided by 4567, divided by 0.234. The answer is 2.845?
Yep.
That sounds right. Now, the entire practice test 3 is done except for page 1. So tonight's homework is page 1. This test is a little bit longer time-wise than some of the others. So those of you who have extended time might want to sign up for extended time this time. I need the forms tomorrow, second period. Who do you check in with?